Yep. So we'll be discussing two courses under me. My two courses. It's cloud computing and edge computing, and basically, I would say the right progression, no, since we are now in the era of edge computing. First, it's intro to cloud computing, and for the course, no, we'll be discussing some terminologies and in cloud computing and especially security, since there's a lot of misconceptions on cloud security, wherein you'll hear a lot of deployment that if it's in the cloud, it's secure. It's not necessarily the case. No? Got some slides here to discuss that. Also, challenges in cloud computing. So it's not all glitz and glamour when deploying in the cloud. There has to be a lot of considerations involved to the cloud. And some of those issues are actually solved by edge computing. No? So, of course, there's the benefits and trends, no? In cloud computing, that's going to be part of the course. So in discussing of what really is the cloud, we have some early history here where in the early days of computing, we were really into centralization, no, of applications, since not everyone has a terminal or personal computer or workstation. Everyone is have just basically a terminal, sorry, a basic access to a central mainframe computer. No? And this basically is a centralized approach. And towards the 1980s, where personal computing was proliferating, it became somewhat decentralized. No? But the computing power then wasn't that good initially, no? Until around early 2000s to until now. The progression of speed of computing in storage and processing and memory access has been increasing significantly. But now realizing that we have a lot of data, no, we need a way to centralize it, which basically spawn, no, yung cloud computing industry. And come to think of it, no, parang from centralized, we made it decentralized. Now we are centralizing again in cloud computing. But when we did that for the past 15 years, we do realize that there are issues that cannot be solved with cloud computing. Hence, we need, of course, something to be processed on the device itself. So that's the challenges. And now we're trying to somehow decentralize stuff again. Well, not everything, but we are now more how you call this, informed, no, on what we could do centrally better, and what we could make, how to make it more efficient, no, and responsive when processing it on the edge devices. So for this, got some discussions on major cloud providers, in which case it's mainly AWS, Azure, and Google Cloud. No? That is our, I wouldn't say insignificant, no, but they do have their own the niche market on why would you be using Salesforce Cloud or IBM Cloud or Alibaba Cloud. But typically, it's just gonna be the top three, AWS, Azure, and Cloud. We actually have an exercise in the course where you would be required to sign up, no, for free service course for AWS, Azure, and Google Cloud, and then figure out how to make basic instances and do some remote access and install some web applications, no? And basically have a feel on how you could manage devices in the cloud and gain experience on it too. Okay. So for that, we got a few terminologies here on cloud computing services, like of course, what's infrastructure as a service. So this is typically your AWS compute instances, where you are given a virtual machine and then you would have to manage it from the OS up to the application layer. And then another layer, abstraction layer on top of it would be platform as a service, like maybe GitHub, GitLab, no, where you upload the code, you have a continuous integration and continuous deployment. That basically is a platform, no? Or and on another abstraction, if you don't want to manage the OS and the hardware part, no, we have software as a service. This typically, I would say, equate this to the likes of Google Cloud, G Suite, no? Where you have your Gmail, your Gdocs, your G Drive. That is an application. It is a software, but you're accessing it mainly through a browser or some client application. but the back end, no, isn't handled by you. No? The storage, the compute, the memory, the patching, it's all handled by the service provider. So it's unlike a infrastructure as service where you need to manage the OS and patches and security. In software as a service, they do most of it, except for the security part would be your credentials. You have to manage it on your own. Now, for the types of cloud computing, well, we have, of course, the private cloud. You could still have your own cloud in your infrastructure, no? Well, you will be deploying virtualization platforms, no? Like VMware or Zen or Citrix, and you would be managing your instances, your storage, your bandwidth. But that means also the procurement of the hardware, the storage, and location of your servers in the data centers, the cooling, the power. It's gonna be under your responsibility. No? If you don't want that kind of capex, basically, you could go with public cloud, like AWS, Azure, and Google Cloud, no? Where or even the smaller ones like Linode and DigitalOcean. No? Well, you could subscribe to them. It's pay as you use. Instantiate whatever systems you need, and of course, you need to also compute the cost implications. No? Because if your environment needed 100 node instances, it's definitely going to be costly. But of course, if your revenue is matching, no, that requirement, then shouldn't be a problem. And we've been seeing a lot of this in the last one. It's the hybrid cloud, where it's a combination. No? You have your private cloud for maybe critical, mission sensitive, or confidential data processing cloud environment. And then you have your public cloud integrated with it, where you have all, well, basically the internet accessing your service. So this is not uncommon. We even got part of a hybrid cloud, no, wherein some systems are in Azure, some systems are in AWS, and then you have a few systems in DigitalOcean, and then you still have an on-prem. So that's not an uncommon deployment. It tends to be a bit more complicated because now you're dealing with multiple platforms, no, but it is possible, and I have seen it, and I have maybe uh, a bit been wonky on the justification on when they needed that. But I understand there are some instances that they need really two major public cloud providers. Their justification, one of their justification is if one of their cloud providers gets hacked, they need to be able to spawn the service on another one quickly at that. So, like if it's just AWS, now imagine the risk if your root admin credential was compromised and the threat actor is able to take control of all of those. No? So you're basically gone. So the one use case that I have seen is they were able to justify that they need the assured platform, no, to have some sort of business continuity in case AWS goes down. It's not really gonna go down, no, but there are instances where AWS has some outage, Azure has some outage, Google Cloud has some outage. There are instances where each and every of this platform has been hacked. Not necessarily because of the platform's fault. It's mainly, let's say, a user has a weak credential, or they were phished. No? They were conned into giving out their admin credential. So we got that discussion there. And this nicely translates into security. No? So again, there's a lot of notion that if you are into cloud computing, your system is secure. But again, depends on where you're at. No? So if it's infrastructure as a service like AWS EC2 instances, do note they have what we call shared responsibility model, where AWS deals with the hardware, the availability zones, the compute, the storage, the database, the networks, and the software for the cloud. But it's your responsibility on the operating system, the configuration, the software that's gonna be running on those instances, and even the identity and access management. So that's on you. So I've seen a lot of cases of cloud breaches where they thought they're secure because they put the systems in the cloud, not realizing that they did not architect their system in favor of the cloud. They mainly migrated to the cloud without much changes. No? So that's basically one of the pitfalls here. That should not be the case. Hand in hand, there is also in Azure something similar like yung shared responsibility model of AWS. Azure also has one. Okay. For our discussion in the class, we'll be checking out the Cloud Security Alliance Cloud Control Matrix. So this basically gives us a framework to our security checks, no, on the cloud with 17 domains to cover and 197 control objectives. Now, of course, we don't have enough time to discuss all of this now, but this is the major 17 modules in the CCM, especially the version 4. This is the new one. So some challenges in cloud computing, to be discussed in the course, core security. We also got compliance challenges and vendor lock-in. So typically, you might not have enough resource to have access to multiple cloud, but you'll need specialized engineer to operate your AWS instances, and Azure would be a totally different animal. So you need a specialist there too. So, but if you need to choose one, you're most likely not going to be able to migrate out of a cloud provider easily because again, you might not have the skill set to operate the other on another cloud vendor. So that's going to be a problem. Issue on data migration slash bandwidth. A lot of organizations work with fail to realize data migration issue where they have terabytes of data that they need to put into the cloud, and the bandwidth becomes a problem. Luckily, some major cloud providers already offer solutions like ship us your disk drive, the physical disk drive, and they're gonna load it for you. And that's a lot faster. No, never underestimate the bandwidth of a hard drive on an airplane. Typically, that especially if we're talking about terabytes or even petabytes of data, that's definitely going to be a lot faster than shipping this data via the wire, the internet. And on the bandwidth side, issues like, we have it on-prem. We were running it at 40 gigabits per second. Now we move it to the cloud. Do we actually have 40 gigabits bandwidth to have access to those data as if it's locally here? Probably not. No? So again, a lot of these considerations and challenges should be um, heavily considered and addressed, no, before we move to the cloud. No? But that said, cloud is, I would say, a mature technology. It has been there for, I would say, even the start of the computing history, no, where everything was centralized in the 1960s, 1970s. That's technically cloud computing to a degree. No? But we're just making it more hyperscalers. Okay. And next we have the next topic, no? Edge computing, where we'll be discussing key components, challenges and limitations of edge computing, and what's the uh, similarities between cloud and edge, and of course, the difference between those two. So in edge computing, basically, how is this different from cloud computing? Well, as the name implies, this is a part of the distributed computing paradigm where when we moved to the cloud, we basically attempted to centralize everything. No? But now we have some issues. No? We realize that we have 100,000 devices and we want those data to be processed in the cloud. Um, First issue would be shipping those data to the cloud and having the processing capacity, no, for that information, and then sending the data back to the devices. No? So that for a time has been acceptable, but as you deal with multiple or millions of devices, no, that's becoming not so scalable. No? I mean, of course, the cloud could handle it, but do you actually have the money and resource to shoulder that when the billing arrives? No, so edge computing was conceptualized. As part that they want the endpoints, no, or IoTs to have a little bit of processing power and decision making capability, no? And process the data, send it to edge computing platform. They have some mini edge devices or edge gateways on near the infrastructure, no? And that it could centralize it but closer to the edge, no? And have those all those data that is already processed being sent to the cloud or the data center. So short history, it's of course based on content delivery networks in the 1990s, no, to serve videos and softwares and patches. But by 2000s, no, this CDN basically involves into hosting apps and eventually hosting edge servers, no, to the nearest to the clients as possible. And one major platform that actually does this, no, type of CDN is Netflix. Netflix is mainly hosted in AWS, so that's cloud. But you don't expect Netflix to host their movies, no, in AWS. That's going to be very expensive for them if each and every individual, no, would be streaming from AWS. So what they did was they have these mini servers. I wouldn't say mini. I would say medium to large servers, colored red, that they ship to multiple ISPs. Okay. And what AWS really is for, it's used for Netflix is just to manage the accounts and billing. Okay, and some AI predictions on what would you want to do to watch next based on your previous history. So that's I would say that's very minimal resource requirement, no, as compared to hosting the movies in AWS. So what they did was they have this servers that they send, no, to multiple ISPs that actually hosts the movies. And of course, it has a limited capacity storage, so even though it's a few terabytes. But what's happening is they could predict which movies would be watched at what time. Okay. And they would get that na from central servers and host it locally. So if you are, let's say, on Globe or PLDT or whichever telcos you are in here locally, and you want to watch, let's say, a new series, no, in Netflix, um, you would be requesting it to your AWS central server, and then the AWS central server would say that, oh, you are in PLDT, based on your IP address, go to this URL. It is an internal machine within the PLDT network. Get your movie there. Or you go there and you're from Globe side of the town. No? Netflix would know based on your IP address where you're requesting from and say, okay, you're from Globe, hence I have this server hosted in Globe. Go there, there is this movie, and you could retrieve it. And now the bandwidth is contained within those ISPs. It's not gonna go out of the telco's infrastructure, which also saves, no, a lot of bandwidth, not only from Netflix, no, even for ISP. Uh, you just imagine if all those Netflix subscriber would be getting their information from AWS. It's also gonna saturate the telco. So this is a win-win situation for both of them. So that's how, at least on storage wise, no, how an example of how edge computing would work. It's you're bringing those resources as nearer to the clients as possible. We got just a short clip here, no? uh, stating, no, that used to be that you don't need local servers anymore. You move to the cloud, but eventually now you have an edge device, no, for your computing needs. But it still talks to the cloud. Someone has to have a holistic view of what's happening on the infrastructure anyway. So again, this is data generating endpoints. Okay? They could somehow process it, okay, and then send all this telemetry or analytics result, no, to the cloud and have the cloud process this. And this solves three major issues with cloud computing. The scalability side, as mentioned, no, you don't want to have all this storage, all this bandwidth being harvested in the cloud. It's going to be very expensive. It is doable, but you might not have the money or business case to make that kind of architecture. Hence, you need to make this storage, no, like the Netflix scenario, closer to the client. There's also volume, which, well, source, like, moving to the example of the Netflix, no, the volume of data would be an issue. Now, on video streaming site, latency wouldn't be that much of an issue, but imagine if you're from the Philippines and you are retrieving your movie from, let's say, somewhere in Europe. No, the latency might affect your viewing um what do you call this experience. No, if latency is high, chances are your codecs might attempt to reduce the bit rate, because again, if you're looking into network connectivity experience, no, it's not just the bandwidth. Bandwidth's a big part, no, but latency also affects your experience heavily. Even if you have, let's say, a 10 gigabits per second, but if your bandwidth, your latency is 1 second, no, per packet, no, it's not, that's not fun. So, but if you make these edge devices as closer or even on the device itself, that solves a lot of your issues. Okay. So key components discussion, I have here discussions on edge devices, edge gateways, edge data centers, and of course the centralized clouds, and how would analytics come into play, no? Like use case of AI on cameras, wherein it would process if it detects a person. You typically don't want to send those data all the way to the cloud, and then the cloud will decide if there's a person or not, right? Typically, you want to get the data from the camera sensor and then have an onboard processor with some machine learning imputed into it and determine if, yes, the camera is seeing a picture, I'm gonna send this stream to the cloud and eventually alert, let's say, physical monitor, security monitoring people, no? That there's a person on the premise, which you might want to determine if it's authorized or not. And I'm not sure if you've seen on some buildings here in the Philippines. No, I've seen facial recognition, building access, where you would be registering your face, and then there's cameras in the floors and in the elevator that would alert, no, if you are not in the floor that you're supposed to be, based on your initial access. Of course, there's also challenge and limitation on edge computing. Like, of course, it's near or on the device. You have limited computing power and storage. Got, of course, security concern. If you're processing data there and that data gets stolen, how do you mitigate that risk? There's also, of course, infrastructure and deployment cost. While you're trying to minimize the centralized cost of the cloud, now you have a lot of uh, initially dumb devices, but now if you want to compute and store something, well, there's going to be cost for it. The connectivity and the scalability for edge computing, and of course, power consumption management, because typically this device, especially IoT, so some segment of it would be operating on battery. And we all know, but it has been insignificant, leading to a bit more insignificant over the years. Now, where if you put in security, it needs more computing power, therefore more power consumption. And if it's a low end device, you typically want to conserve battery. And I've seen a lot of IoTs and sensor networks, no, forgo with security because they want the system, no, to live longer in on battery. And then there, of course, maintenance and management. If it's a red sensor device that you leave somewhere without any road access, no, and the battery dies, who's gonna pick it up and replace the battery, or maybe just have a new device that's gonna place there, no, and retrieve the old device for operations and maintenance too. So, and just in the interest of time, I won't be seeing here, but we'll be discussing similarities in the course with edge and cloud computing, of course, differences too.